Section 7.1, I'm going to break that into 2 lectures. Talks about estimating a population proportion. So descriptive statistics would be a proportion, mean, and standard deviation. Plus probability, find a level of probability, equals inferential statistics altogether. Remember, this is where you make a prediction about the population proportion, the population mean, and the population standard deviation. So, really quick, let's start with an example to explain how this is going to work. So, estimating a population proportion. Look at the tray of beans that you brought to class today. Let's say we brought this to class today. We are going to try to estimate the percentage of black in the tray. So the percentage of black compared to white. What percentage of the tray contents do you feel are black beans? Now here the answer could vary. You could write whatever you guess. I'm gonna guess that this is roughly, I'll say 75%. So here the answer could vary. You could pick whatever you want. How could we find out if we are right? Well, there are a few ways we could figure out whether we're right. We could count them. Right? We could take a sample, but the sample has to be large. The sample that we take a large sample, right? We could take away mean. So there are a few things we could do. Based on our sample, the instructor's best guess is that the true proportion of black beans is between 80 and 90%. Alright, let's say the teacher said that in the tray. So the proportion is between 0.80 and 0.90. That's what proportion is. It's really percentage. What level of agreement do you have with this guess? Well, my guess here, if you chose 75, you might somewhat agree or somewhat disagree. You could say, actually, you know what? So, any of those three. But, if the instructor is saying these are 75, if you're saying there's about 75, and the teacher is saying that's between 80 and 90, most likely you're going to be here. Your instructor has revised their guess. Now they believe the true proportion of beans is between 70 and 80. Remember, you said 75 in the tray. So the proportion is between 0.70 and 0.80. What level of agreement do you now have with the instructor? Well, probably, depending on what you chose, if I chose a 75, I'm going to probably be here. But if I choose something below, then I'm going to be here. There's a point out of this, of course. One last revision. Now, they believe that the true proportion of beans is roughly between 60% and 70%. So the proportion is between 0.60 and 0.70. What level of agreement do you have with the instructor's new guess? Since they're doing an accurate count, probably you're going to be here or here. Now, what would happen if we take another sample? would we get the same sample proportion? Probably not. But it should be close. And would you like to know the true proportion of the black beans in the entire bag? Well, again, answer could vary. Maybe you say yes, maybe you say no. I really don't know. That's up to you. But you can't answer that wrong. Let me enlarge that a bit. Okay. So here's the deal. The idea is there's a point estimate and there's an interval estimate. A point estimate is a single value used to approximate the population parameter. So, something like saying, how much do you think math college teachers make? You say 66,000. That's a point estimate. So you're picking one single number, right? Note the sample proportion is the point estimate of the population proportion. So, sample proportion is the total successes, the successes over the total, which is really a probability. It's really x over n. So it's just like probability proportion. But here it's like percentages, which is the probability normally. Example, I took a sample of, this is the example. I took a sample of 40 PCC students and asked them, do you think that Sir Bugsley is cute or not? The result were as follows. 24 said yes, Mr. Bugsley is cute, and 16 said no. What is the variable in this case? Well, cute will be quality. This is binomial. Why is that? Well, either you say yes or you say no. There are only two outcomes. And what would be p hat? The probability of success will be, well, isn't that 24 said yes out of 40? That is 0.60. So 60% say yes. That's the probability of success. Of course, q hat, which is probability of failure, will be 40%. Which statement do you think we can make from this point estimate? So 60% of the 40 said that this dog is cute. Exactly 60% of all PCC students think Sir Bugsley is cute, or about 60% of all PCC students thinks Sir Bugsley is cute. Well, we can't be exactly sure, but around 60%, because we only asked 40. From this sample of 40, we can imagine that there may be some error, right? Associated with taking a sample from a population. We will create an interval around P with the hope that the true proportion of P lies within that interval, and we state a certain level of confidence we have. You take the estimate and you add and subtract a possible error. So when I ask how much you think college teachers make, you might give a number, 66,000 per year, for example. But that's a point estimate. Most likely, they make either above that or below that. But if you take that point estimate and add and subtract a number, say, 3,000, then you will end up with an interval between, so 66,000 minus 3,000 is 63,000 to 69,000. The chances of how much a college teacher make being between 63,000 and 69,000 is higher than it being exactly 66,000. So an interval is much better to get a true value, and then you guessing the right number exactly. Same thing with age. I look at a student and say, you know what, how old do you think I am? If I say 19, well, probably they're not 19. But if I say between 18 and 20, there's a higher chance that the actual number is between 18 and 20 than it being exactly 19. So a confidence interval, that's what this is. A confidence interval, abbreviated CI, is a range or an interval right there of values used to estimate the true value of the population parameter. So we're trying to guess how much the teachers or college teacher makes. We put two numbers. It's easier for the true value to be between those two numbers than for us to guess it exactly. A margin of error is like the 3000 that you give or take. The maximum likely difference between the observed sample proportion and the true value proportion. And normally we find the margin of error. This is from the next sheet and on. We're going to find it exact depending on the level of confidence. We'll talk about that in the next lecture video. For now, we're going to focus on this and get this out of the way before we proceed and talk about the rest. So n, you know. P hat we already found. Q hat is 1 minus. The only thing we have to worry about is Z sub alpha over 2. That's for the next lecture, not for this lecture. So, if the margin of error is 8%, so if the error is 8%, then what interval would you expect the true proportion of all PCC students to be who think Sir Bugsley is cute? Well, if the error is 8%, I'll take the point estimate, add and subtract the error to it. That would be 0.62, or 60, or 60%, right? Plus or minus 0.08. So instead of saying 60% of PCC students, we would say if you take 60 minus 8, that's 52%. And if you take 60 plus 8%, that's 68%. So you take the point estimate, you add the error, and you subtract the error. That gives you an interval. This is called a confidence interval. Very important. So, for us to say, we think somewhere between 52% and 68% of PCC students think that that picture is cute or that dog is cute, is more likely to be true than us saying, oh, 60%, exactly 60%. So, effects on the width of the confidence interval. 1, the sample size. That's a big deal, right? The smaller n is, the larger the error is. And the larger n is, the smaller the error is. Think about it. The more students you ask, the more closely you're going to get to the true value. And confidence interval, and we abbreviate that with CI for confidence interval. That's what we're going to use all throughout. The lower the confidence level, the more narrow the confidence interval is. The higher the confidence is, the wider the confidence interval is. Now, when you say lower confidence interval, if you want to be, 80% or 70%, versus if you want to be 90%, the higher the confidence you want, the bigger the interval should be. And the way it works, P hat is really, if you want to find P hat given a confidence interval, you would take the lower end plus the higher end and you average those. That gives you the average, always. So that is, get the calculator out. I didn't think we were going to calculate anything in this lecture, but I was mistaken. So I could do it, that's 120 divided by 2, or 1.2 divided by 2, but if you put parentheses, 0.52 plus 0.68, right? You don't have to do that. You could say it's 1.2. You could say divided by 2. One shot, right? I just want to show you that that's what it was. And that gives you 60%. And if you want to find the error given a confidence interval, so given a confidence interval, the error would be 0.68, the end minus the beginning, divided by 2. And I could go back to that calculator, go to that problem, and subtract the 2. Of course, I should put the 0.68 first, or I could just take the opposite of this. That would be 0.08. That's the error. So given a confidence interval, oh boy, I'll get it right. Third time will be a charm. Given a confidence interval, if you add the endpoints, divide them by 2, you'll get the proportion. And if you subtract the endpoints, divide them by 2, you'll get the error. Now, homework. Page 324. I need you to do number 1 through 4 all, and number 9 through 12 all, before I proceed and wrap this up.